So right now, once we saved our model, so in the work directory we have, as we just mentioned in the previous video, right now we created the our model .caa file. So this is the model database file. This is our main file, okay. And by default also ABAQUS generates this other file. This is called the .jnl or the journal file. And the journal file, you can delete this file, but you don't need to, but you can, of course. It will not affect anything, but generally this journal file is very useful in case something crashes during your modeling when you are doing your model, if the program crashes or something. So using the journal file, ABAQUS can recover what you have done, okay. But practically, you only need the CAE file to transfer to a different PC or something like that, or opening from somewhere else. So you only care about the .caa file. Okay, so we go to our next step, which is the definition of parts. So this is the part module. So this is the first one. Of course, once you click here, once you're already on the part module, you see here on the left, so between the tree model, let's minimize it a little bit, and the viewports, you have here a number of icons. So these are all the options that you have, or these are all the controls that you have with respect to the part module. As you will see later, once we move to the property module, these icons will change. They're ones relevant to the property module. Again, if you go to the step, they change, and so on and so on. So now we are in the part module, and pretty much the first thing that we want to do is to model our sections. So we are going to start with the first one, that is the column section over here. So our column section, these are the dimensions. It's 200 in height, 200 in flange width, 10 millimeter. These are all dimensions in millimeter, by the way. And you have 10 millimeter web thickness and 15 millimeter flange thickness, and you have here a radius, the fillet radius is 10 millimeter. So we're going to model this as a solid element, and this is 1.5 meter long. So before I start doing that, just be aware that we haven't selected any units, and you are not going to see any units in ABAQUS when you are defining anything. So it's your responsibility, it's the user responsibility to make sure that all the units are consistent. So you have to decide before you start modeling what units are you going to use to define your model. So in my case, or for this tutorial, I'm going to be using Newton for forces. I'm going to use millimeter for displacements or measurements. Distances, that's pretty much it. So Newton and millimeter, like for the purpose of this tutorial. But of course, if you're doing something like with thermal, perhaps you need to decide, are you going to use Celsius or something like that, for instance. So basically we are going to be using Newton and millimeter. So let's go ahead. So first we'll start with the part. So we want to create a new part. So this basically goes here. So this is the first icon that we have here. It says create part. So this is the one that we are going to use. The rest of the options, these are all additional things that we can do to the part. But what we are going to start with is create part. So if you go ahead and click on create part, you are going to get this dialog box. You need to give a name for your part. So of course we are going here, I'm trying to model a column, so I'll just call it a column. Okay, so you can give any name to your part. Of course, by default, once we open this, it was called like part 1. Don't use the default names. Always when you are trying to model something, always give it the proper name, so that when you come back to it later on, you remember what it was. So we are going to use a column. Then you need to select what is the modeling space. Are you modeling something 3D, or you are modeling something 2D or axis symmetric? So in our case, we are modeling our problem in general. It's a 3D model. So, and here I'm trying to model a 3D part, so I'm going to select 3D part. Then you need to select the type of this 3D part. Is it a deformable 3D part? Is it something that's going to deform as part of your analysis? So yes, so that's why by default this is the first one, this is the one that we are going to use. There are other options as well, discrete rigid, analytical rigid, and the Euler type. So basically discrete rigid and analytical rigid, those are all ones if you want to create a part, but you don't care, like this part, you are not going to assign it a material, you are not going to assign it a mesh or anything else, because this part will be something that's rigid, so you don't need to worry about that. So instead of creating this part as a deformable, instead you can go ahead and you can select it as an analytical rigid or a discrete rigid. So these are all other options that you can use for creating the part. But again, with respect to what we are doing now, we are going to use a deformable element. Then this is the base feature. So this is pretty much the shape. Are you doing a solid? Are you drawing a solid? Or are you drawing a shell? Or are you drawing a wire or a point? So these are the three shapes that you can model in SAP. So what we are modeling right now, we are trying to model a solid. When we are modeling the beam, we are going to use a shell. When we are, if you want, this is not part of this tutorial, but if you are trying to model like line elements, like wires, pretty much, then you can use wires. If you want to do points, then of course, clearly you are going to do points. For now, we are going to use solid. And then this is the type. This is pretty much how are you going to draw this. Are you going to do this with an extrusion? So basically, this is what we are going to do now. We are going to draw the cross section of the column, and then we are going to extrude it in the 3D space using the length, of course, of the member. Or you can, depending on, of course, the shape of your part, you could do like some kind of revolution. So you draw part of the cross section, and then you say, okay, I want to revolve this in the 3D space with a given angle. Or you can use sweep if you have like something with some curvature in the 3D space. But for our case, we are going to use extrusion. But again, the others are basically for other types of geometries. Here, the approximate size, this is, you need to give like some approximate size. You can leave it as it is, it doesn't matter, but pretty much once we click continue, what we will have, our viewport will transform into a sketching plane, and pretty much here ABAQUS telling you what is the size of this sketching plane, all right, to fit the grid and so on. This doesn't matter actually. If you put any number, it will not matter. Like you can draw whatever you want, but of course if you put the correct number, this will aid in making things visually simpler. So here we are trying to model a section that's 200 by 200. So I'm going to leave it as 200 actually, which is the maximum dimension of my cross section. So I go ahead and say continue. So as you see here, so now all these icons now changed, and right now I have a grid of a sketch grid, and over here, as we said, like always pay attention to this part over here of your interface. Pretty much ABAQUS is telling you what to do next. So here ABAQUS is telling you sketch the section for the solid extrusion. So this is what we need to do. We need to draw the sketch of our cross section. You can zoom in and zoom out using the scroll on your mouse, of course. So if I zoom out like that, so you have, this is the sketch, like the grid that has been created by ABAQUS based on the 200 that we provided. There is a rough number. As you see here, by default in ABAQUS, you always draw into the XY plane. Okay, so this is by default, you cannot change that. And then of course, it will be extruded into the Z direction, all right? Later on in the assembly module, you can change the orientation, or you can rotate the part later on. But as part of creating the part, you always draw in the XY direction. So if you want to change the sketch right now, you can go over here to the sketcher options. If you click on that, you can modify some options. Like if you want, right now once we start drawing, you will see that automatically we will be snapping to the grid just to make the drawing easier. So you can do that. You can change the size sheet. Right now it's 200, which is what we created, and the grid spacing is 5, which is 5 millimeter based on what we chose. So you can modify all these things if you would like. This is fine. The grid, the origin right now, it's at 0 and 0. So you are drawing at, this is from the point 0 and 0. So you can modify that if you want, again, using the origin or the angle of the sketch. So pretty much you have many things that you can control over here. Dimensions, showing the dimensions, constraints. So you can do constraints, of course, as we're going to see here once we draw our cross section. Image is very, very useful in some cases. So for instance, if you have a part that you know how it looks, but it has like a very complex geometry or a curved geometry or something like that, so it could be easier if you show an image. So pretty much this is to put like a watermark or put a background here. So you import an image, and then pretty much you can trace around the image by drawing lines or something like that, so curves around the image for your part. So this is very useful in some cases as well. So you can see we are going to discuss this later on, like how to use this image in later more advanced videos. So I will leave this as it is, like using the default. Don't need to change that. So right now, of course, I need to draw on my sketch, and then here I have like the basic drawing controls, like what you have in any kind of CAD software. So you can draw points, you can draw lines, you can draw circles, rectangles, and well, pretty much what you want. You can do trimming, you can do mirroring, you can do different things. So what I'm going to do here, I'm going to use, actually I'm trying to model this cross section. So what I'm going to do, this cross section is pretty much the easier way to do it. We are going to draw this flange using a rectangle, and we're going to draw this other flange again using another rectangle, and we are going to draw the web using a rectangle. This would be the easiest perhaps way to do it, but again there are many ways to draw something. So this is what we're trying to draw. This is our cross section. All right, so this is 200 by 200, and the thickness, as we see here, is 10, and the thickness of the flange is 15. So try to keep these numbers in mind right now. So let's go here. So let's start by drawing a rectangle. So I click here on that. So right now ABAQUS is telling me, as you see over here, it tells me what you need to do next. It says pick a starting corner for the rectangle. So pretty much I'm going to draw this rectangle using 2 points, one corner and the opposite corner. So I can do here by just going on the sketch and clicking on the first point, the first corner, and then clicking on this the other corner. And as you see here, as I move, you can see here the coordinates, X and Y coordinates, they appear over here. The sketch has the size of 200 by 200, but the sketch doesn't mean anything. I can start drawing outside the sketch. All right, so that's why I mentioned that the sketch size is not really fundamental in this case. So I will try to draw. So over here you see this is the origin, 0 and 0, and ABAQUS is already snapping to the grid points. So every like 5 millimeter automatically it snaps. You can, as we mentioned, you can modify those from the sketcher options. So what I need to do, I need to go to a specific point and then draw the rectangle. So the first coordinate will be 200 minus 15 minus 15. So that would be 170, right? 200 minus 15 minus 15, this is 170, and this divided by 2 because we are going to measure from the center line. So 170 divided by 2, this will get me the first point. So this is pretty much 85, right? So 85 is the elevation, and in the horizontal direction, this is negative 100. So if I go back to ABAQUS, I can go to negative 100 in the X direction. So that's negative 100. Let's see if I can snap. So this is negative 100. And in the Y direction, we said we want to go to 85. So pretty much this point over here. Of course, as you see, okay, this is not the ideal way of doing things. Like here, I can click on this point. So now I clicked on this point. And right now I can move to the next corner, which is actually what ABAQUS is telling you over here. It's telling you pick the opposite corner of the rectangle. So the opposite corner will be at positive x 100, and now 85, we need to add 15, which will be 100, which of course would be the edge of our sketch. And then I click, and that's it. So now I have the rectangle that we mentioned. This is of course not the ideal way of doing things, just drawing like that. Perhaps sometimes it's easy to do that, but you can, in the same time, you can directly put the coordinates. So here it's telling you right now, it's expecting you to draw another rectangle, which actually we are going to do for the lower flange. So it's telling you that pick starting corner, so you can do that directly from the sketch, or you can enter the X and Y points, the coordinates. So here I'm going to do that actually for the other rectangle, just as it changed. So now I'm going to draw the lower one. So the lower one will have a negative 100 in X, and will have negative 100 in Y. And then I click enter. So as you see it right now, it has been updated. And then I'm expecting to put the other corner. So this would be positive X, X of positive 100, and then Y would be negative 85. And then I click enter. So now I have my other rectangle. As you see here, the rectangle it has been drawn automatically. You have these labels, like you see H. It says H over here. Like if I zoom, it says H. So H means that this line, it has a constraint assigned to it that it's horizontal. All right. You can delete this constraint, but I will leave it. That's fine. But typically you can assign constraint to some lines. And over here, you have the perpendicular label over here in the corners. So mainly this is a constraint that says that this line is perpendicular, always perpendicular to this one. So this means that if I want to modify something, let's say that if I modify this length, which this is something that you can, we're going to see this in a second. If you modify this length, then what will happen is that this length of this side will increase. For instance, if you make it larger, and in the same time, because you have all these constraints that this line needs to stay horizontal and the angles need to stay at 90 degrees, the opposite side will also increase with the same amount. If you don't have these constraints, then this line will increase, and then you will have an inclined line. So the constraints, you can add constraints from here. You see here there are different constraints that you can add. Okay, so this is adding constraints. You can say, okay, I want this line, this line to have a fixed length. So if I select fixed, then it will tell you, ABAQUS will tell you, okay, select the line that you want to fix its length. If you want to have something parallel, then it will tell you, ABAQUS will tell you, select the lines that you want to keep parallel to each other, and so on. So there are many constraints, and these are very helpful, especially if you want to create something that you want to change dimensions later on. So this makes it much easier. So I close this for now. So let's draw the final rectangle. So that's the one for the web. So I click again on the rectangle. Again, I will use, so the rectangle is 10 millimeters. So perhaps I can go ahead here. We go to -5. So this is X -5. And then I move to X +5 here at the same edge. And then I'm done. So right now we finished the flanges and the column, but of course we still don't have the radius yet. Okay, so the fillet radius, we need to model this. So this is, we have fillets at the edges, And in the same time, I have a line over here, but this is not good. In order to do a solid extrusion, the area inside needs to be a continuous area. So you need to have a unique perimeter around the section. So right now I have this line between the two parts, so this needs to be removed. So we are going to use the trim option. So if I go here to the over here, so this one, it says auto trim. So I'm going to click on this, and then right now it's telling me select the segment of a curve to delete. So if I zoom a little bit, and then if I click on that, and then I click again because we have two parts, and I click again, so now this has been removed. This part has been removed in between. And I do the same here for the top. Click again, and then it trimmed this part that I want to remove. So now my section is good. The only thing is remaining. So now if I want to finish, I can click again on the icon, or I can click escape on my keyboard, and then I'm out of this trim option. So right now let's do the fillet. So if I click here, this is the option to create a fillet. So create a fillet between two curves. So if I click on that, so the first thing that you need to specify is the fillet radius. Based on our section, it's 10 millimeter, and then I click enter. And right now it's telling you select the first entity near the end to be filleted. So pretty much this is each corner. So I select this line, and then I select this line. So now I have my first fillet, and then I select this line, and I keep going ahead. I have my second fillet, this one, this one, this one, this one. So now you have some annotation, and again some constraints automatically provided by ABAQUS for the dimensions. So that's it. We finished with the cross-section drawing. That's where we are done. Before I move, let's just go through some other things. If you see here, some of these icons, they have like a very small, I don't know if you can see it on your screen. There are very small black triangle here in the bottom right corner. So whenever you have an icon that has this small triangle, this means that if you click on this, so this one right now, it says auto trim, for instance. So if I click using a left click, if I do a left click and then I hold the click, I don't release, then you will get other options. So this means that there are different things behind this button. So right now we have the trim, the auto trim, but there are other things. You can select extend, you can use a split. So there are many other options behind this icon. All right, so right now, again, I'm holding the left click in order to access these other options. So the same thing for anyone, like this one, for instance, it says translate. So if you want to move a sketch from one location to another, if I hold on it, you will get other options like rotating a sketch, mirroring, so you can do a mirroring for a sketch, and so on. All right, and if you want to delete something, like if I draw a line, for instance, let me draw something here. Let me draw like a circle, so with a center line, something like this, and I want to delete it, you just click on delete, click on it, because it says here select the entities to delete, and then you say done, and then it's removed. And then I click escape just to go out of that. So as you see, it's very straightforward, typical drawing. So what else? So now we're finished with that. Another thing that maybe I want to show you, if I want to modify dimensions. So you can add dimensions if you want to make sure, so you draw this thing, but you don't remember, did you do it correctly? Was the thickness of the flange correct or not? So you can go here in this icon, it says add dimension. You can click on that. And then it says click on the entity you want to dimension. So if I click on this one, for instance, and then I can move it anywhere. So right now it says 15, which is correct, but you have the option. So right now it says new dimension. So if you want to modify it, you can modify it now. So you can say like, for instance, 30. So if you do that, you see, now it increased, and it increased in this direction and everything is perpendicular. That's because we have all these constraints. If you want to undo, then you can undo the last action. That's fine. You can add the dimension and just keep it as it is, 15. You don't change it. But later on, if you want to change it, you can click on edit dimension value. So if I click on that, I can click on the dimension, and then again I can modify it again. So this is how the basic controls again that you need to do. So now we are done. So sketch the section for solid inclusion. Yeah, we drew everything. Everything is correct. So now let's click on done. And right now, since we are done with the sketch, so now we are doing the extrusion, the 3D extrusion. So now you are asked to provide the depth. What's the depth of your cross section? So based on the problem that we are trying to model has 1.5 meter. So that's 1500 millimeter. You can have other options. If this member like is twisting while it's being extruded, it has some kind of revolution, maybe if you have this kind of geometry, or if it's inclined, or if like the member has some kind of inclination to it, so you can include this angle over here. But in our case, it's a straight extrusion, so just provide the depth, and then I will click OK. And once I do that, so now the part has been created. So right now under part, you can see that I have the part that we created, column, and this is how it looks. And over here in the model tree, you can access, if I expand under part, you see now the column, and then you can expand more under column. There are many things you can do to this section, like assigning section assignment, as we're going to do later, like doing the meshing, creating sets or like surfaces. But again, this is something that we are going to do later on. So right now I have my part, so I will leave it as it is for now. So next, let's do the shell part. So this is the shell part, this is the second one, this is for the beam. So see you in the next video.